All right, here we go. We're going to divide polynomials. I don't know if you remember long division. Well, I'll tell you what, before we do the long division thing, let me show you some easier division. This is not long division. This is kind of basic division with polynomials. All right, so this first part shouldn't be that difficult. I'm sure that you've done this in Algebra 1, the thing that we're going to do right now. So I wrote down this. I put remember. Okay, what if you had something like this? I'll be very general. Won't use any numbers on this one. Over D. What would you do with this if you were to divide? You had a sum up here. You got these things being added or subtract. You could put subtract there as well. But if they were being added, you got a sum up there and everything was being divided by D. What does that mean you should do? It means you should take A and do what to it? Divided by D, then plus what? Yep, B over D. Everybody got it? Plus C over D. Yeah, pretty simple. Because if I went the other way, what would I have to do to add fractions? Find a common denominator? It's already there, isn't it? Everything's got a D, so you put it over 1D, and then A plus B plus C. See how that works? All right, so with that in mind, let's do an example, and we'll call this example 1. And it says to divide. Sometimes they might just say simplify, but this one says divide, so here we go. It's 3x squared y cubed plus 9x to the 5th y, that's supposed to be a 5 right there, sorry, it's kind of ugly, y z squared, let's make that look like a 5. Oops, there we go, that looks a little bit better. Minus x to the 4th, y z to the 5th. And this is all over 3xyz. 3x. It is a lot. But it's not hard. It's pretty simple. It is, I promise. Let me scroll back down a little bit. Right there. I'll keep that there. Okay, so we're going to use this little, I don't know, it's not really a formula, but I guess you could think of it that way. This little technique, that's a good word to use, this little technique on dividing by the denominator. If you have a single denominator like this, all these things are being added up, what can you do? You can take this 3x squared y cubed and put it over 3xyz, right? Because everything's being divided by this 3xyz. This is being divided, so is this, so is this. All right, so we're going to rewrite it. Tell you what, so make this, I don't know if this will be faster or not. Probably won't be. All right, so you got this over this. Correct? I just write it. Probably faster that way anyway. 9x to the 5th yz squared over, well, since I already got it copied, might as well use it. Yeah, see, by the time I do all that, I probably could have just written the thing. Minus x to the 4th y z to the 5th over 3xyz. Everybody see that? Yeah, pretty easy. I just took this one, divided it by that, then this divided by that, and then this one and divided it by that. But I just made them all separate. Now, what you always have to do, always in algebra, is to simplify. So let's see what we can do here. How are we going to simplify this division? 3 divided by 3, what happens with those? They basically cancel out. We say they cancel out, but really what's happening? 3 over 3 is a what? It's a 1, and it's just 1 times anything. So, but we say cancel, and I'm fine with you saying cancel. I know some teachers don't like to say cancel. They say they divide out, but I'm okay with cancel. What do we do here? I got an x squared on top and an x on the bottom. So here's how I think of it. Everybody watch. One of these x's cancels out with what? One of those x's. So how many am I going to get left over on top? Just that one x. See what I did? All right. What about the y's? This y will cancel with just one of these y's. So how many am I going to have left? I'm going to have 2 of them. It was 3. All right. So it's y cubed, but I took one out, right? And then I got y squared left. You with me on that? So I should have done those canceling things in different color, but it all kind of runs together. What do we got left now? On top, we got an x, and we got a y what? Squared. And on the bottom, just a z. All right, so that's the first term. And basically, we do the same thing to this. I mean, this is a very Algebra 1 type of topic, isn't it? Yeah. So what do we do here? 3 goes into 9 3 times. So we got a 3. X goes into x to the 5th, x to the 4th times. So I got an x to the 4th. The y's both just cancel out. This z goes into this just once, so I got a z on top. So what else do I have? I got a z on top. Is that right? Over what's left on the bottom? Nothing, which is a 1. Okay? They all cancel. Remember, they all divided out to be a 1, didn't they? All right, so when I say nothing, it doesn't mean 0. It just means there's nothing left. You put it over 1. Do you really even need that over 1? You don't need it. That would be fine like that. Okay? And then one more, minus. And then what do we do here? There's no numbers, so what's going to be on the bottom with my numbers? 3. All right, and then the x's, that's going to go what? 3 times? So that's going to be an x cubed on top. The y's just cancel out again. And then the z, that goes once, that goes 4 times, so z to the 4th. That is your answer. That's about one of the easier division problems that you're going to do in here, okay? And that wasn't too bad, was it? Yeah, pretty simple. Again, a very Algebra 1 type of thing to do. All right, so we went to Algebra 1. Now we're going to go back to, I don't know, when did you do long division? Maybe 4th grade, 3rd grade maybe? Anybody remember? 4th? 3rd or 4th, probably. All right, so here's what I'm going to have you do. I'm going to have you divide. This is not in the book. This is the number I always use just to before I teach this long division stuff. Let's divide 7 over 8. Okay, so 7 divided by 8. So we're going to do a long division. All right, we're not going to use our calculator. Oops, let's make this look a little bit better. Well, that's not much. Good enough. So I always, which one goes inside? I call this the box. Which one goes inside the box? The 7. Okay, I always say the top goes in the box. I always say the top goes in the box, or box top. I think I had a teacher a long time ago who said that, and I always remembered it from, I mean, that was like 45, 50 years ago. Who knows? Okay. Yeah, 10th grade or 10 years old. Yeah, that's probably when I did long division, something like that. So yeah, probably 50 years ago. I remember box top. All right, so the top goes in the box. Can you remember that? All right. And then, of course, the 8 goes out here. So now we're going to do some long division. I'm going to go kind of quick, but this is just to refresh your memory, because what we're going to do is we're going to do this same kind of thing, but we're going to do it with x's and y's and squareds and cubes and all that kind of thing, okay? Polynomials. Everybody got it? So watch what we do. Now, does 8 go into 7? No, it doesn't. So we go to, well, let's do this. Put the decimal. We're really not going to put a decimal in what we're going to do in a little bit, but on this one we would. Now we say, how many times does 8 divide into 70? It doesn't go even, but it does go a certain number of times. Okay, 8 times. Good, because 8 right there. And then now what do we do? 8 times 8 is 64. Then what do we do with that 64? We subtract. Do you remember that? Okay, and so we're going to subtract. 70 minus 64 is 6, and what do we do now? Bring down the 0. Everybody good? All right, now you say what? 8, how many times does 8 divide into 60? How many times does 8 go into 60? 7 times, right? 8 times 7 is 56, right? 8 times 8 is 64. That's too big, right? So we use the 7. Put the 7 right there. We multiply now. So 7 times 8 is 56. What do? We subtract the 56, and then we actually do the subtraction, which gives you a 4. What do we do now? Take that 0 and bring down the 0. So it's coming back to you. 8 divides into 40 exactly 5 times. So we don't have a remainder. That's nice. And there you go. Well, we do have a remainder. What is the remainder? Technically it's 0, but yeah, we don't have a remainder. All right? And that's how you do a long division. Is it coming back to you? Yeah. Seems like nowadays, I don't know if teachers are teaching this or not. They might just be say, put it into a calculator. What's that? Yeah. This is the way I learned it. I like this way. It's good. Plus, it's a good, how how would I say this? Not a mirror, but it's just, I don't know, it's a good way to look at what we're going to divide now. There's another way I should say it, but here we go. You ready for a real example? So this is example 2. What we're going to do is we're going to use this process right here to divide some polynomials. And this is what we're going to do. So x cubed plus 4x squared plus x minus 6. And we're going to divide it by, so we're going to say divide this by x squared plus x minus 2. Now, over here, when you did this division, you were dividing by a monomial, a one-term expression. Everybody see that? So that was pretty easy. But now, we're not dividing by a monomial, we're dividing by a what? A trinomial, okay? Sometimes you'll divide by binomials. I'm surprised they didn't put a binomial in here, because usually the first example is a binomial, then they kind of work you up to this. But maybe they're thinking that you've already had some of this before. So here's what we're going to do. We're going to set up a long division problem just like we did earlier. All right, so which one goes in the box? The first one, right? That first big old thing right there. So that's what we're going to do. So put it in there. So x cubed plus 4x squared plus x minus 6. And what are we dividing it by? What goes on the outside, our divisor? It's x squared plus x minus 2. And this is what we're going to do. We're going to do a long division with all this mess. Everybody here? All right. Simone, you with me? All right. Remember how I tell you what, let's do this. I like to have this. I'm just going to grab that and then put it over here off to the side, just so we have, still searching for that word. I got it like in my head and I just can't think of the word. It's kind of like a representation, a model maybe. Yeah, it's not exactly the word I was looking for, but it kind of works. Okay, it's kind of a model of what we're trying to do right here, all right? So we went 8, how many times does 8 divide into 70, correct? Now over here you got 3 things. So all I'm worried about is the first one for now. Okay, we're going to do the rest of them in a second, but let's just do the first one right now. So we said, how many times does 8 divide into 70, correct? All right, so what are we going to do here? What I'm going to do is take my first one, the x cubed, I'm going to say, how many times does x squared divide into what? X cubed. It's not 1, it's an x. It's an x to the first. All right, everybody see that? So how many times does x squared divide into x cubed? Or you could just look at it and say, what's x cubed divided by x squared? Okay, either one means the same thing. And how many times? 1x, right? So you just put an x right there. Now, what did we do over here? We said 8 divides into 70 8 times. We put it up here, and then what did we do? We multiplied, then we subtracted, correct? So now what I'm going to do is take this, and I'm going to multiply it by this and subtract it. But I'm multiplying it by 3 different things, aren't I? It's not just 8 times 8. All right? Make sense? All right. And then we're going to subtract. What I do, when I do these, I put my subtraction first, and then I put a parentheses. All right? Some people don't put the subtraction. You're going to get messed up if you don't, okay? I always put the subtraction there, then I put a parentheses. Why do I put a parentheses? I didn't put a parentheses here. Well, because I got 3 different things here, okay? And I want to subtract all 3 of them. So now, what do? Over here, we went 8 times 8. What are we going to do here? X times x squared plus x minus 2. So we just do a little distributive property. We can do that in our head, can't we? So x times x squared is x cubed. X times, it's a positive, plus x times x is x squared. And then this is a minus, right? Because that minus right there, x times 2 or 2 times x is 2x. It's not so bad, is it? Now, what do? What do we do over here? We subtracted a 64, didn't we? So now we're going to subtract here. Just got to be careful, though. because remember, you got a minus on the outside. So you're subtracting this, subtracting this, subtracting this. So x cubed minus x cubed is 0. Don't need to write it down. I'm not going to. Let's go to the next one. 4x squared minus 1x squared. What is that? 3x squared. Now put it right underneath of there. See how all the x squareds line up? We got one more, don't we? Minus a negative 2x. What's minus negative 2x? It's plus 2x. That's what I said. 1x plus 2x is 3x. Okay? All right. So, basically, this is where we're at right now on this one, our little model. Okay? So, what do? After we subtracted, then you say, how many times does 8 go into 60? So, what are we going to do here? How many times does x squared divide into 3x squared? Right? Yes. Thank you. Bring that down. Good call. Keep me on my toes. Now what do? How many times does x squared go into 3x squared? Or 3x squared what? Divided by x squared. What is that? It's just a 3. So how many times does it go into it? 3 times. So you just put a plus 3. We good? Let's multiply and subtract. 3 times x squared is 3x squared. 3 times x plus 3x. 3 times negative 2 is a minus 6. Now we subtract. 3x squared minus 3x squared is 0. 3x minus 3x is what? 0 again. All right? And then negative 6 minus a negative, so it's negative 6 plus 6 is what? 0. So guess what? My remainder is 0. So this is my answer. Sometimes you will get a remainder, all right? Like the next one. Yeah. When's this over? 14? All right, I gotta keep moving. Does that make sense? If you wanted to check, we're not going to, but this, like right here, 0.875 times 8 would equal what? 7. All right, same thing here. X plus 3 times all this will equal this thing right here. Okay? Let's do another one. This will be the last long division that we do. There's a better way to do this, a lot better way, and you're going to like it so much more than this. All right, I'm just going to... They say this. I might as well write it the way they write it, because if you see it like this in the book, you'll say, what are they asking? It says, determine whether x minus 2 is a factor of this thing right here, 3x cubed minus 8x squared plus 14. What does that mean? Is it a factor? If it goes into it evenly, perfect, okay? If this divides into this evenly, if it divides into it evenly, just like we did the last one, okay? Did this divide into this evenly? It did. How do we know? Because the remainder, what was our remainder? It was 0, okay? So if I divide this and my remainder is 0, then x minus 2 must be a factor. You follow? All right, so basically what we're doing is just doing this division and then just checking out what the remainder is. All right, so let's do the division. What are we dividing? We're dividing this by this, x minus 2. So the x minus 2 is going to be on the outside of the box. Whoops. You got to be kind of careful, though, on this one, okay? I'll start you off. 3x cubed minus 8x squared. But what's missing? Like what term, if you want to look at it that way, is missing here? You got an x cubed and x squared, but then you jump to a constant. You need a what? You need an x in there somewhere. So what am I going to make that x? make it as 0x. So plus 0x. All right, so if you have an x cubed, you got to go all the way down the line. You got to fill in every place value. All right, so you got an x squared or x cubed, x squared, x, and then you have a constant. All right, that's really important that you do that, because then when you bring stuff down, you won't be able to subtract. If you tried this without a 0x, you're going to find out that you need something there to subtract the x from. All right, and that's what it is. Did it change the value of it? No, because it's just added a 0, right? So I didn't really change the value of it, but I did make it so that when we divide, it'll all work out. So let's go a little bit faster since you kind of have a basic idea. I'm not going to write all that stuff down. 3x cubed over x, what is that? That's 3x squared minus, and then let's multiply and we'll put it here. So 3x squared times x is 3x cubed minus 3x squared times 2, which is minus 6x squared. Okay? And then we drop everything down. That's a 0. This is negative 8 plus 6. What's negative 8 plus 6? Negative 2x squared. Hunter, this is going to answer your question. So now, what do we got to do? Bring down the next number. Well, actually, the next step will answer your question. Everybody with me on that? You'll see after we do that next multiplication why you need that 0x there. So now we ask ourselves, how many times... yeah, I can bring down the 14. Okay? And how many times does x divide into negative 2x squared? So basically, you're just going negative 2x squared divided by x. What is it? Negative 2x, correct. Okay? So you're just taking this and dividing it by the x. Forget the minus 2 for right now. Just look at the first one, okay? Take this, divide it by x. And now, we got it up here. It's negative 2x times, so now we multiply, then we subtract. So I got negative 2x squared. And then what do I have now? Plus 4x, correct? Now, Hunter, look at this. See, if I didn't have that 0x there, I wouldn't have anything to subtract from, right? I would have had the 14 there, and then you can't go 14 plus 4 or minus 4x, okay? Does that make sense why you have the 0x there? All right, good question though. So watch, negative 2 minus a negative is plus, so those add up to 0. What about this one? 0x minus 4x is negative 4x, bring down the 14. Now, do this. Negative 4x divided by x is just negative 4. Then we multiply and we subtract. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. Negative 4x minus negative 4x, that's plus, that's a 0. This is 14 minus 8, which is 6. Nothing else to bring down, so what is that 6? That's my remainder. Okay? Yeah, you could write this particular question just says, is x minus 2 a factor of this? So is it? No, because you have a remainder other than 0. Okay? Does that make sense? So that's all we're doing for this particular question. Yes. All right, so that's all they want you to do for this. If you have a remainder other than 0, then x minus 2 is not a factor. So technically your answer is no, x minus 2 is what? Not a factor. But I know what you're asking.
Can't you just tell that by looking at it, though?
Not always, no. Okay. So you could write it like this. So what's your answer? 3x squared minus 2x minus 4. You could just put R6. That's what sometimes they let you do. All right. But another way to do it is since that's a positive 6, put plus 6 over whatever you're dividing by. What are you dividing by? No, you're dividing by this one right here. Okay, so that's another way to write it. So you could write it like that. It's probably the preferred way to do it. Kind of the simpler way is put the R, but most of the time they would have you write it like that. Okay, you want to see a better way to do this? I just have enough time. All right. Do they use the same numbers? 3x? Yeah, they use the same exact numbers, don't they? So let's do that same problem, and we're going to use the same exact numbers. Excuse me. This is example 4, yes. It's called synthetic division, and I'm just going to show you how to do it within the example, okay? It's just an easier way to do it, and it really comes in handy. So watch, 3x cubed minus 8x squared plus 14, and we're dividing it by, they don't really put the division here, they put divide by, and then, but you could write it like that, that's perfectly fine. In fact, in my pre-calc class, you have a problem that's almost identical to this on the test they're taking tomorrow, okay? So we will be doing a lot of this stuff in pre-calc as well. Here's what we're going to do. We are going to do, our long division symbol looks a little bit weirder. It just looks like this. And what we're going to do, we're dividing it by a thing, I think they use the letter K, x minus K. So what we do is we put the K right there. So what number are we putting right here then? Is it a -2? Remember, it's just the K. So there's your x, there's your minus. What's your K? It's just a 2, so you put the 2 here. What if it was x plus 2? Then what would you put inside that box? Put a -2, because what is this? This is x minus -2. You with me? So there's your x, there's your minus, this is your K, and that's what would go here. All right, but since it's just a 2, we put a 2 right there. Now what we're going to do is take the coefficients of all your terms. Whoops. Take all your coefficients, and remember you had you got an x in there as well, all right? And then we're going to just list them out like this. So what's my first coefficient? 3, then -8, always take the sign. You got to have something for the x. What's my x? A 0, and then my constant is a 14. Now watch this. This is so much easier. It's so much cleaner, and it's just really slick, all right? What we're going to do is this. We're going to take that 3, and we're just going to drop it below that line. That's the first step. Everybody can do that, right? Now, you know how we multiplied, we subtracted, multiplied, subtracted on that long division? That's what we're doing here. So we're going to go 2 times 3 is what? 6. We're going to put it right here. And then we're just going to, now we're not really subtracting though this time. I shouldn't have said that. We're going to add up these columns. Okay, so we're going to add these columns up. So it's -8 plus 6, which is -2. Make sure you put the right sign. And then you just follow that pattern the rest of the way. All right, so what's this? 2 times -2 is -4. You put it right here. With me? So you're not always going times the 3, but you are always multiplying by this 2. So it's 2 times 3 goes here, 2 times -2 goes here. Then you add these up. 0 minus 4 is -4. Do it one more time. 2 times -4 is -8. You put it here. You add them up. What do you get? You get 6. So how do we write our answer? We don't just write it just a bunch of numbers next to each other like this. Do you see how this was an x cubed? This number right here is always going to be one exponent less than what we started with. Okay? So what's this going to be? This is going to be our x squared. Or you could look at it this way. Here's the way I like to look at it. This is always going to be your remainder. This is your constant. This would be what? What's your next step up? This would be your x, and then this would be what? Your x squared. You see that? So now we're ready to write the answer. So what is it? It's 3x squared. What's this? Minus 2x. What's this? Minus 4 with a remainder of 6. And that is way easier, don't you think, than doing all that. But it's the same exact answer. Pretty cool, huh? So why didn't you show us this in the first place? Is that what you're telling me? Well, you got to see kind of where it comes from. All right, we only got a couple minutes. Let's do one more, and then we will be finished. We're going to use synthetic division to take x cubed minus 7x plus 6, and we're going to divide it by x plus 3.
Does this only work when it's just like an x plus 3?
This,
Or like an x minus
This works when I should have said this, when your lead coefficient is a 1. You must have your lead coefficient to be a 1, okay? And I would like to say you only use this when you're dividing by a binomial. I'd have to look that up a little bit, okay? They probably explain it in the book when you can use synthetic division, but when they say use synthetic division, you know you can use it, okay? So we'll say it that way. But this needs to be a 1. So what are we going to do? Put that little weird division. What's going to be inside that little box right there? It's a -3 this time. Now you put your coefficients. You start off with an x cubed, and that's a 1. What am I missing here? X squared. So what am I going to put for x squared? A 0. And then now I can go to the x, which is -7. Now I can go to my constant, which is a 6. Right? Put a line, but leave some room because we're going to put some numbers in between. All right? Just drop the 1 straight down. And now we do our math. Very easy math. -3, you put it right here, you add them up. +9, you put it here, you add them up. -6, you put it here, and you add them up. So is x plus 3 a factor of x cubed minus 7x plus 6? Yes, it is. What I just said right there, eventually, I think we do it in this, I don't know if it's in this chapter, but I think eventually they do this in this Algebra 2 book. We did it in the pre-calc. That's what we're taking a test on. But the fact that that is a 0 and this is a factor of this is really important, okay? So what is this? This is our remainder. That's our constant. That's our x. And this is our what? X squared. So it's 1x squared minus 3x plus 2. You don't have to put anything for the remainder because it's 0. And that's your answer. So how many times does this go into this? It goes x squared minus 3x plus 2 times. There you go. Again, that's called synthetic. I don't think I wrote that down, did I? It's called synthetic division. All right? So we're doing 1 to 31 odds. Just the odds. Okay? And it's section 6.5. All right, there you go. Just the odds. So that's only what, like 15 problems? 16 problems, something like that? All right, have fun with that.